Howdy guys, another quick little supplement to our lecture. I wanted to go over one way that you can use the periodic table as a map to work out your electron configurations, because I know some of you have been struggling with it. You're trying to figure out, when do I jump from 4s to 3d, then back to 4p? How do I handle the f orbitals? How do I know what orbital comes next? And the whole point of what we're doing here is that all this theory is meant to explain the organization of the periodic table and to give us some predictive power over that. And so to show you how the orbitals stack up when it comes to the Aufbau Principle, we can use this essentially as a map by thinking about what areas we're filling which orbitals. So when we begin, of course, the first thing we generally fill is going to be 1s. And so hydrogen and helium, we've got a pair of electrons that go into the 1s orbital. After that, we hit the 2s. And as we saw in class before, that's 2 more electrons, so that would take care of lithium and beryllium. After that, we would need to go on to 2p, which we can sort of see reading along with the diagram from the ivory sheet. After that, it's 3s and 3p, and then comes that first surprise, because we know we have the 3d orbitals still lurking in the n equals 3 shell, but we're not ready to fill them just yet. Instead, what we do is we jump over to the 4s. And so what I want to point out to you is that you still see this very consistent tendency to put electrons into the s orbitals whenever we're on this side of the periodic table. By the same token, when we're over here and we're filling in electrons for a particular element, we're going to be working in the 4p sublevel. And so the same thing's going to happen all the way down through here, 5s, 6s, 7s. And in fact, these two groups of the periodic table, the alkali metals and the alkaline earths, are frequently referred to as the S block. By the same way, 5p, 6p, 7p over here, those 6 groups are referred to as the P block. And what happens in between 4s and 4p, we know from the diagram from last time, is that we put electrons into the 3d orbitals. And the same thing's going to happen every time we hit the transition elements. We're going to be putting electrons into d orbitals. The next time down it'll be 4d, then 5d, and then 6d. And in our search for the other type of orbital that you're going to encounter, the f orbitals, those are getting filled when we're in the lanthanides and the actinides, split off from the periodic table. We split them off, and you can see that when we get to 6s, the last thing we hit is barium, and then we hit lanthanum, and that brings us down into the lanthanides. And so this is where we'll begin to fill up 4f, and then in the elements near thorium, protactinium, uranium, etc., we'll be working in the 5f sublevel. And so what I want you to really focus on here is that you can build this map no problem for yourself if you know 2 things: where the blocks are, S, P, D in the middle, F set off to the side, and if you know the first level where that kind of orbital shows up. So we start with 1s right off the bat for hydrogen and helium, so every level has an s orbital. It's only when we get to n equals 2 that we see our first p orbital. So here we go 2p, 3p, 4p, 5p, 6p, 7p. We get our first d orbitals in the 3rd energy level, in n equals 3. And so even though this is in the 4th period, I'm still starting from 3d, because that's the first set of d orbitals I encounter. 3d, 4d, 5d, 6d. Same deal with f. I don't begin to fill them until I hit period number 6. However, the first f orbitals are 4f orbitals. They're part of the n equals 4 shell. So that's got to be 4f, this has got to be 5f. And now if I want to come up with a particular element's electron configuration, all I need to do is read my way through this, and I'm at least going to get the Aufbau compatible version of it. So for example, if I'd like to do astatine, which is all the way down here, element number 85, right before radon. Well, coming up with that electron configuration is now really as simple as reading my way through this. I'm going to put electrons into 1s, so 1s2, then 2s, 2s2, 2p. How many go in there? 6. Okay, 2p6, and then again 3s2, 3p6, 4s2. Now I'm not guessing about whether I need to jump over to n equals 4 or not. I have it right here. 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, and now I come down into the F block for the first time, 4f14, now back up to 5d, 10 in there, and then I run out of electrons here in 6p, so 6p5 for the rest of astatine. And again, if I want to do this from our sort of abbreviated version, the way that we handle it with noble gases leading off, again, I can look just up here and notice that I've got xenon hanging out at the end of 5p, and so I can call this xenon, and then look at my diagram to see that the next place I need to go is 6s. 6s2, 4f14, 5d10, and finally 6p5. Okay, so that's how we get one of these from this diagram.